Hey guys, I'm kind of zoomed in here. We're going to be doing two different kind of labs today, judging how speed and mass affects collisions. And this could be part of car design, car safety, but we're also going to be applying the stuff that we've talked about with balanced and unbalanced forces. Some elements that you have for this lab. We do have a ramp. It has different notches indicated by A, B, and C. A is the highest, B is the medium, C is the lowest level. We have our meter stick. We're using centimeters. We have a wooden block to represent the object being hit. And then you also have two pieces of ramp. Two track pieces. And this is just to demonstrate the road or just to allow the car to move. And then we have our lovely little cart, which is this turquoise type of object. Also, you have some space inside, and we'll use the space inside when we do the second part of this lab. So first things first, let's talk real quick about force and how it is applied to different objects. Remember that force is a push or pull. Also, force can allow things to change in position. That's how we have balanced and unbalanced forces. Then you can have different sizes of forces. We know this from doing net force. If it has a value, we know it is unbalanced. And if it is zero, we know it is balanced. Our unit is always newtons. Length of time can influence the force. Also, collisions happen so fast, so short amount of time can also influence the forces of objects. And importantly, we know that a force is a push or pull. So we've done the different labs in the past, but what we're going to do is test how this cart influences this wooden block. We're going to do this different times because remember, you want more than one trial to get enough data so we can get an average over a long period of time. So what we're going to do is you're going to have your cart. We're going to use the back spindle or spigot, whichever way you want to say it. We're going to line it up to the A notch. Okay, the handle right here of the cart is what's going to come down and hit the block. We're going to see how far that block moves from the back. And again, this is only going to go centimeters. It's not going to go off the table, I promise you. We're going to do this 5 times at each height of the back spindle. So 5 times at A, 5 times at B, 5 times at C. And we're going to get our data. And then we're going to get our averages to kind of compare the different heights and how that would influence a collision. And then we're going to answer some questions. So let's go ahead and do the first trial, which would be at part A. So we're at our highest point on our ramp. And we set the block 5 meters from the bottom. So if I move my my meter stick, so it's at 0, so it's a little easier to calculate. We measure from the back, from where it got hit, so kind of like a fender bender. It moved 9 centimeters. Okay, let me grab a pencil real quick. And I will put up my data later so you guys can see. So for trial 1, I have 9 centimeters. Always include your units. So I reset my block every time. So now I'm going to do it again at part A. It went 9 centimeters. Got to reset. That time it went at 10. Can't read today. 10 centimeters. Reset. We have 10. Calculators are our friends, y'all. You've had a long day of teaching. LOL. And then we reset for the last time. And we get 9 centimeters. So the way we do this now is we do our average. So I'll do 9 plus 9 plus 10 plus 10 plus 9. And I get 47. Well, that was our total. Now we divide by the number of trials we did. And we did 5 of those. So you do 47 divided by 5. And you get 9.4 centimeters. So that's how far the object's going to move at the highest point. You're going to do the same thing for the medium and then your lowest height. Okay? And then I will put up the data on the screen so you guys can see what we came up with. So some questions we want to answer is, how does the speed of a cart affect how far the block moves? Well, think of it like this. The faster something is moving, the more damage is going to get done to the car. Number 2, why do you think the release height has this effect? Well, if you're at a higher incline, you're going to have to apply more brakes or resistance, thinking of friction, in order to slow down. And this does not have brakes. So at a higher incline, it's going to have more of speed coming down the hill. And sometimes in experiments, we think about experimental designs. How could we change the design of this experiment? Maybe we could have used something other than a wooden block, maybe something of a different medium. Okay, maybe make a larger scale, which would be cool. And the last one, when a car crashes, do you think the speed can make a difference in the amount of damage done? Well, we know if people, especially on rainy days, not being careless drivers, a lot of things can happen. So speed, you got to be careful going the speed limit on the roads, and safety is first. All right, so that is part 1 of our speed collision. The next one we're going to do is mass collision, which is very similar. So for part 2, remember, mass is the amount of matter in an object. So it's what you're made up of. Think of it like volume. Does the mass of an object affect the force being applied during a collision? Well, that's kind of your hypothesis. So we're going to test using different cylinders. How mass is affected. You're going to do this at the different height. The first one would just be 0. You would always reset. So without a cylinder, we're going to do this 3 times to save a little bit of time. And you're going to let it release, and then the block is going to move. Then we're going to add a cylinder. Then we're going to do 3 trials. Okay? With that cylinder at the highest point. Every time we're going to add a cylinder. We're going to add a total of 3 cylinders to get some data. And then I will put the data on the screen. So then we can answer these questions. Does the mass of the car affect the collision? Why do you think mass did or did not have the effect you predicted? Could we have designed this portion of the lab different? And if you were in a car collision, would you rather be hit by a vehicle that was 2,027 kilograms or a vehicle that was just 1,000 kilograms? What would your response be? Would you want to be hit with like a moped or a tractor trailer? All right, y'all. So that is the second lab. Have fun studying, and I'll talk to you guys later. Contact your teacher if you have any questions. Bye.